What if scientists discovered that sleeping just 5 minutes longer, moving for less than 2 minutes, and making one tiny diet tweak could add an entire year of life for those with the worst habits? What is the cellular chemistry behind this remarkable biological leverage? The scientific pursuit of human longevity has long been dominated by an all-or-nothing paradigm. Standard clinical preventative health guidelines frequently advocate for demanding lifestyle overhauls. 90 minutes of high-intensity aerobic training, rigid 8-hour sleep windows, and extreme dietary restriction regimens. Yet observational data in behavioral epidemiology indicates that the vast majority of the adult population fails to sustain these highly restrictive protocols over the long term, leading to an immense gap between theoretical longevity advice and practical patient adherence. But what if the human biological system does not actually require behavioral perfection? What if a series of microscopic, almost imperceptible shifts across multiple physical behaviors could compound to add nearly a decade of high-quality, disease-free life? Recent clinical evidence has officially verified this hypothesis, exposing the underlying cellular and system-level science of the minimum effective dose, or MED, for human health span and longevity. In January 2026, a landmark prospective cohort study was published in the Lancet's eClinicalMedicine journal under the title Minimum Combined Sleep, Physical Activity, and Nutrition Variations Associated with Lifespan and Health Span Improvements. Led by Dr. Nicholas Komel and a team of international clinical researchers from the University of Sydney, the study tracked 59,078 participants with a median age of 64 over an 8-year follow-up period. This investigation was fundamentally distinct from prior lifestyle studies because it bypassed unreliable self-reported questionnaires. Instead, participants wore clinical-grade wrist accelerometers for 7 consecutive days, allowing advanced machine learning algorithms to map high-resolution movement and sleep micropatterns. Diet was comprehensively evaluated using a validated 10-item diet quality score. It is crucial to explicitly note that this landmark UK Biobank study is a prospective observational cohort study, not a randomized controlled trial. While it reveals a powerful epidemiological association between behavioral patterns and life expectancy, it cannot establish direct causal proof. However, cellular and molecular pathways offer a highly plausible biological framework to explain these findings. To understand the findings, we must make a crucial scientific distinction between 2 entirely different scales of behavioral intervention. First, consider the microdose intervention. For individuals with the poorest baseline habits, specifically defined as the 5th percentile of the population, who average just 5.5 hours of sleep per day, 7.3 minutes of physical activity, and a poor diet quality score of 36.9, the theoretical minimum effective dose to gain 1 additional year of lifespan was incredibly small. It required just 5 minutes of extra sleep per night, 1.9 minutes of moderate to vigorous physical activity per day, and a 5-point improvement in diet quality score, such as consuming an additional half serving of vegetables daily. On the other hand, consider the macro dose optimization. Moving all the way from the lowest tertile to the optimal tertile, which means sleeping 7.2 to 8 hours, performing over 42 minutes of daily moderate to vigorous physical activity, and eating a high-quality diet, was associated with a massive 9.35 years of additional lifespan and 9.45 years of health span. Most importantly, health span in this study was strictly defined as years spent living completely free from 5 major age-related chronic illnesses: cardiovascular disease, cancer, type 2 diabetes, chronic obstructive pulmonary disease, and dementia. To understand why adding as little as 5 minutes of sleep can influence clinical outcomes, we must examine the brain's cellular waste clearance mechanism. During slow-wave sleep, characterized by highly synchronized cortical oscillations, the brain's interstitial space expands by roughly 60%. This expansion facilitates the activation of the glymphatic system, a glia-dependent clearance pathway that acts like a nightly hydraulic flushing cycle, exchanging cerebrospinal fluid with interstitial fluid to wash away toxic metabolic waste. This system is driven by Aquaporin-4 water channels polarized on astrocytic end feet. When sleep is chronically fragmented or shortened by even minor increments, these Aquaporin-4 channels lose their polarized alignment, shifting away from the vascular end feet. This causes glymphadenopathy, leading to the rapid accumulation of neurotoxic proteins like beta-amyloid and phosphorylated tau, which are the primary pathological hallmarks of Alzheimer's disease and cognitive decline. Simultaneously, chronic sleep restriction disrupts the hypothalamic pituitary adrenal axis, elevating evening cortisol levels. This cortisol elevation triggers systemic inflammaging, which is a low-grade chronic inflammatory state marked by elevated interleukin-6, tumor necrosis factor alpha, and C-reactive protein. This state actively accelerates cellular senescence and telomere shortening. By extending sleep duration by just 5 to 15 minutes, the sleep architecture is stabilized, reducing microarousals and microglial activation, and providing a critical window for neural restoration. While traditional exercise guidelines demand continuous, long-duration workouts, the science of vigorous intermittent lifestyle physical activity, or VILPA, reveals that extremely short, intense bursts of movement are highly potent. According to supporting mechanistic evidence from Professor Emmanuel Stamatakis' related studies, accumulating as little as 1.5 to 4 minutes of VILPA daily, spread throughout the day in bouts lasting under 60 seconds, is associated with a 45% reduction in major cardiovascular events and up to a 67% reduction in heart failure among non-exercising women. In men, a daily average of 5.3 to 5.6 minutes of VILPA was associated with a 16% risk reduction in major cardiovascular events. The cellular mechanism behind this rapid adaptation lies in the AMP activated protein kinase, or AMPK pathway. During brief, vigorous muscle contractions, such as rapidly ascending 60 stairs, cellular energy reserves are depleted, causing a spike in the intracellular ratio of AMP and ADP to ATP. Essentially, when the skeletal muscle cell's metabolic sensors detect this sudden energy crisis, they sound an emergency alarm. This alarm causes the glucose transporter 4, or GLUT4 vesicles, to swing open their gates and fuse with the muscle cell membrane, pulling glucose directly out of the blood via an insulin-independent pathway. This immediately clears glucose from the bloodstream without placing a demand on the pancreas. Second, AMPK, along with muscle contraction-induced calcium release, activates the PGC1-alpha pathway. This master regulator stimulates mitochondrial biogenesis, increasing the density and respiratory capacity of mitochondrial networks. Even a 2-minute stair climbing snack acts as a physiological wedge, breaking up prolonged sedentary behavior and preserving metabolic flexibility. In the SPAN framework, a 5-point increase in diet quality does not require a restrictive dietary overhaul. It represents the targeted inclusion of fiber-rich, prebiotic-containing whole foods, such as half a cup of cooked vegetables or a serving of whole grains. When these indigestible complex carbohydrates reach the distal colon, they are fermented by anaerobic commensal bacteria, yielding key metabolites known as short-chain fatty acids: acetate, propionate, and butyrate. These molecules act as chemical messengers with profound epigenetic effects. Short-chain fatty acids directly inhibit histone deacetylases, or HDACs, within mucosal immune cells and epithelial tissues. This epigenetic relaxation of DNA structure upregulates the transcription of the FOXP3 gene, driving the differentiation of naive T cells into regulatory T cells, or Tregs. Tregs release the potent anti-inflammatory cytokine interleukin-10, dampening localized and systemic inflammatory pathways. Furthermore, butyrate serves as the primary fuel source for colonocytes, reinforcing the cellular tight junctions of the gut barrier. This prevents the translocation of pro-inflammatory bacterial endotoxins into the blood, directly halting the inflammatory cascade that drives secondary aging. Concurrently, a higher quality diet reduces the persistent overactivation of the nutrient-sensing pathway known as mTORC1. By lowering the intake of refined sugars and ultra-processed foods, mTORC1 is downregulated, which restores the cellular cleanup process of autophagy, allowing the body to degrade damaged proteins and senescent cells. When examining the data, a critical trend emerges. Healthy behaviors do not exist in isolation. They operate as a tightly coupled, dynamic network. Improving diet quality in isolation often shows no statistically significant association with reduced mortality because a physically inactive, sleep-deprived body lacks the cellular architecture to utilize high-quality nutrients. Without AMPK activation to open the glucose sinks in skeletal muscle, and without slow-wave sleep to clear neurotoxic proteins and normalize cortisol rhythms, high-quality dietary inputs cannot fully counteract systemic pathological stress. However, when sleep, physical activity, and nutrition are modified concurrently, even by minuscule increments, the synergistic effect is non-linear. A combined improvement of 5 minutes of sleep, 2 minutes of MVPA, and a 5-point DQS increase breaks the self-amplifying pathological loops of aging. Decreasing sleep loss slightly lowers daytime fatigue, which increases the likelihood of engaging in physical movement. Increasing movement slightly improves insulin sensitivity and stabilizes circadian feedback loops, directly enhancing slow-wave sleep depth. This synergistic feedback loop is why the overall dose required to achieve clinical benefits is substantially lower when all three areas are targeted together. The evidence is clear. Clinical outcomes accrue on a continuum, and perfection is a false barrier to long-term health. By shifting focus away from extreme behavioral overhauls and toward the strategic coordination of lifestyle micro-upgrades, individuals can systematically lower their biological age. Adding 5 minutes of sleep tonight, climbing a flight of stairs for 2 minutes this afternoon, and adding half a serving of greens to dinner represents the most scientifically supported, sustainable starting point for lifelong longevity. To visualize this longevity micro-upgrade protocol, first, aim for a sleep extension of 5 minutes per night to stabilize N3 slow-wave sleep. Second, add 1.9 minutes of moderate to vigorous physical activity daily, such as climbing stairs, to activate skeletal muscle GLUT4. And third, increase your diet quality score by 5 points by swapping refined grains for whole grains or adding half a serving of vegetables. Keep in mind that while these observational findings are highly encouraging, more interventional studies are required to confirm direct clinical causality. This is Beyond Limit Health, analyzing evidence-based science for peak human physiology. Thank you for exploring human optimization with us. If you want more evidence-based tools for healthy longevity, hit that subscribe button. This content is for informational purposes only. For medical advice or diagnosis, consult a professional. See you next time.